Now here the question is, if gx is twice differentiable real valued function satisfying g double dash x minus 3 g dash x is greater than 3 for all x greater than or equal to 0 and g dash 0 is minus 1, and if hx is gx plus x for all x greater than 0, then hx is which of the following? Now we can write this as g double dash x minus 3 g dash x minus 3 greater than 0. Now we'll multiply everything with e to the power minus 3x. So we can write e to the power minus 3x g double dash x minus 3 e to the power minus 3x into g dash x and then minus 3 e to the power minus 3x, and it is greater than 0. Now this is nothing but this is derivative of e to the power minus 3x into g dash x plus e to the power minus 3x, and it is greater than 0. Now we can write this as d by dx of e to the power minus 3x into g dash x plus 1, it is greater than 0. Now what we'll do is we'll write this as some function, say px. So it simply means that p dash x is greater than 0, which means px is an increasing function. Now if x is greater than 0, then px, it is greater than p0. Now what is px? Px is e to the power minus 3x g dash x plus 1, and it is greater than p0. p0 is 1 and this is g dash 0 plus 1. Now it is given that g dash 0 is minus 1. So that means e to the power minus 3x into g dash x plus 1, it is greater than 0, or we can simply say that g dash x plus 1 is greater than 0 for all x greater than 0. Now if we look at this function hx, which is gx plus x, we can write hx equals gx plus x. When x is greater than 0, then h dash x will be g dash x plus 1, and we have already proved that g dash x plus 1 is greater than 0. So h dash x is greater than 0, which simply means that this hx is strictly increasing function. So hx is strictly increasing when x is greater than 0, and that's your option A. Now here the question is, prove that this function fx, which is this integral from 2 to e to the power x 9 cos square 2 ln t minus 25 cos 2 ln t plus 17 dt is always an increasing function of x for all x belongs to R. Now we have to prove that this function is always increasing, then f dash x is always greater than or equal to 0. So we'll find f dash x. Now f dash x will be 9 cos square 2 ln e to the power x, and here will be 25 cos 2 ln e to the power x plus 17 into derivative of upper limit, which is e to the power x, minus our lower limit is constant, so its derivative will be simply 0. Now this 2 ln ex is nothing but 2x, so we can write f dash x as 9 cos square 2x minus 25 cos 2x plus 17 into e to the power x. Now e to the power x, it is always positive. So here we need to prove that value of this expression is also positive for all values of x. What we'll do is we'll let cos 2x as t, then we can write this function as some gt, which is 9t square minus 25t plus 17, where t belongs to -1 to +1. So it is quadratic expression, but then its domain is bounded between -1 and +1. Now if we find g dash t will be 18t minus 25, and if we put it equals to 0, we'll get this number as 25 by 18. Now rightmost is plus and this is minus. Now in this interval between -1 and +1, we get a negative sign. So that means gt is a decreasing function, and when the function decreases, its maximum value, it occurs at the point where the interval starts, and its minimum value will occur at the point at the end of the interval. So g max, it will occur at -1. Now if we put t as -1, it will be 9 plus 25 plus 17. So it will be 51, and its minimum value, it will occur at 1. And if we put t as 1, it will be 26 minus 25, and that is 1. So the range of this function gt, it is between 1 and 51, which is always positive. So this expression is also always positive. That means f dash x is always greater than 0 for all x belongs to R. That is, this function fx is always an increasing function for all x belongs to R. Question number H is, the following 5 graph in some order plot y equals fx, gx, hx and df upon dx and dg upon dx. We need to find out what is the plot of hx. Now we'll take this first function. When x is less than -2, this function is increasing. So here f dash x, it should be positive. Between -2 and 0, derivative should be negative. Between -2 and 2, again it should be positive. And then after 2, this again should be negative. Now if we look at this graph E, here before 2, this is positive. Between 2 and 0, it is negative. Between 0 and 2, it is positive. And then again this is negative. So graph of E is derivative of graph of A. So this E, it is matched with A. Now if we look at this function, second function, this function increases till this point, somewhere after 2, and then in between approximately -1 and +1, this function, it decreases. So here derivative should be positive, here derivative should be negative, and again derivative here should be positive. So slope of this graph, it corresponds to this function C. So we have two functions f and g and the graphs of their derivatives. So that means this odd one out function D has to be your function hx. So answer to this question is option number B. Now here the question is, if fx equals cot x minus 10x minus 2 tan 2x minus 4 tan 4x minus 8 cot 8x and gx is x cube plus 6x minus 1 and hx is defined as fx plus gx, then identify the correct statements. Now we know that cot x minus 10x, it is 1 minus 10 square x upon 10x. If we multiply by 2 and divide by 2, we can write this as 2 cot 2x. So this is 2 cot 2x. Now if we again use the same fundamental, it will be 4 cot 4x and then it will be 8 cot 8x, and this 8 cot 8x will cancel. So basically this function fx, it is a constant function whose value is 0. So therefore this hx, it is simply gx, and which is x cube plus 6x minus 1. So now we have our function hx, x cube plus 6x minus 1. First question is second derivative of h. Now we find h dash x, it is 3x square plus 6, and h double dash x is 6x, and h double dash pi by 24 is 6 into pi by 24, which is pi by 4, and that means this option A, it is correct. Now h of minus x is minus x cube minus 6x minus 1, which is not equal to minus hx. So hx is not an odd function. Now if we find h dash x will be 3x square plus 6, which is greater than 0. That means h is increasing in its domain. So option C is correct. Now since h is a cubic equation and it is strictly increasing, now at 0 this value is minus 1 and at 1 this value is positive. So its root will somewhere lie between 0 and 1. So this is an approximate graph of hx. Now at 0 value is minus 1. So h0 is minus 1, and if we find h3 is 27 plus 18 minus 1. So 27 plus 17, it is 44. So range of this function in 0 to 3 is from minus 1 to 44. If lambda lies in this range, then this equation will have a solution. Otherwise, it won't have a solution. Now in this case, the values possible are from 0 to 43. That is, there are 44 such integral values possible. The value given here is 7, which is wrong. So the correct options are A and C. Now here the question is, we are given this function fx whose graph is given to us. Now we have defined this function gx as minimum of ft when t lies between minus e minus 1 to x, when x lies between minus e minus 1 to 0. That means in this interval, we have defined gx as minimum of ft. Now from minus e minus 1 to minus 2, this function is decreasing. So this gx will be same as fx. So this value of gx will be same as value of fx. So this function will be same as fx. Now in between minus 2 and 0, so between minus e minus 1 to 0, minimum value, it will occur at minus 2. So here in this interval, this function will be a constant function whose value will be 0. Now it says gx is maximum of ft when x lies between 0 and e plus 1. So here I'll choose the maximum value. From 0 to 2, for any point x, the maximum value will be at 0. So here this function gx will again be a constant function. And from 2 to e plus 1, this is greater than 0. It is an increasing function. So again this gx will be same as fx. So that is the graph of gx. Now the question is, which one of the following statement does not hold good? Range of gx is from 0 to 2. So range is from 0 to 2, which is true. Gx is non-monotonic in minus 2 to plus 2. This is also true because it is a constant function. Gx is a continuous function, which is correct. And gx is an odd function. Now gx is symmetric about y-axis. So it is an even function and not an odd function. So this is incorrect. So the statement that does not hold good is this statement D. Now question number 36 says, if x equal to alpha is point of non-differentiability of gx, then value of alpha is. Now this function gx, it is not differentiable at minus 2 and 2. That means value of alpha is plus or minus 2, and that is option C. Now 37 it says, if the equation gx equals k has exactly two distinct solutions, then sum of all possible integral values of k is. Now it will have two distinct solutions when we draw a line at y equals to 1 or when we draw a line at y equals 2. So this k, it can take the value either 1 or 2. Then sum of all possible integral values of k is simply 3, and that's your option D. Now here the question is, we are given two functions fx x square upon 2 minus 2 cos x and gx x square upon 6x minus 6 sin x, where x lies between 0 and 1, we need to discuss whether f and g are increasing or decreasing functions. Now, if we take this function fx, we can write this fx as x square upon, this is 2, and 1 minus cos x is 2 sine square x by 2. We can write this as 1 by 4 x upon sine x by 2 whole square. Now, if we differentiate this function, we can write f dash x as 1 by 4 and then 2 x upon sine x by 2 into, now here will be sine square x by 2 sine x by 2 into 1 minus x into cos x by 2 into 1 by 2. Now this 2 and 2 will cancel. So we can write this as f dash x equals x upon 2 sine cube x by 2, and here will be sine x by 2 minus x by 2 cos x by 2. Now here we'll take cos x by 2 common. So we can write this as f dash x equals x cos x by 2 upon 2 sine cube x by 2, and here it will be 10x by 2 minus x by 2. Now since x lies between 0 and 1, all these expressions will be positive, and from calculus inequality we know sin x, it is less than or equal to x, and it is less than or equal to 10x. That means 10x by 2 is greater than x by 2. That means this expression is greater than 0. So if f dash x is greater than 0, it simply means that f is an increasing function. So this function f, it is an increasing function. So that completes our first part, which is f is an increasing function. Now we need to prove that this gx is a decreasing function. Now we are given this gx as x square upon 6 x minus sin x. If we differentiate this function, we can write g dash x as x minus sin x into 2x minus x square 1 minus cos x upon 6 x minus sin x whole square. Now we'll write this as 2x square minus x square. So it will be x square minus 2x sin x plus x square cos x, and this is 6 x minus sin x whole square. Now if we take these two together, we can write x square and 1 plus cos x is 2 cos square x by 2, and here will be 2x and then 2 sin x by 2 into cos x by 2 upon 6x minus sin x whole square. So this g dash x, we can write this as, we'll take x 4 cos square x by 2 common. So if we take x 4 cos square x by 2 common, here we'll get x by 2, and here we'll have 10x by 2 upon 6 minus x minus sin x whole square. Now again, this is positive, and again from calculus inequality, x by 2 is less than 10x by 2. So this is less than 0. So this gx, it is a decreasing function. So the correct option is this option C, fx is increasing and gx is a decreasing function. Now here the question is, find all the values of parameter a for which this function fx equals 8ax minus a sine 6x minus 7x minus sine 5x. It increases and has no critical points. Now if we find f dash x, f dash x will be 8a minus 6a cos 6x minus 7 and minus 5 cos 5x, and it should be strictly greater than 0. Now if we can take this a common, we can write 8 minus 6 cos 6x into a, it should be greater than 7 plus 5 cos 5x. Now this 8 minus 6 cos 6x, it is positive. We can write a is greater than 7 plus 5 cos 5x upon 8 minus 6 cos 6x. Now if a is greater than this function, then it should be greater than the absolute maximum value of this function. It will have its maximum value when this numerator is maximum and when this denominator is minimum. Now this numerator will be maximum when cos 5x it is maximum, and when 8 minus 6 cos 6x it will be minimum when this cos 6x is also maximum. So we'll get maximum value of this function when cos 5x and cos 6x, they are maximum. Now we know that maximum value of any cos x is 1, and luckily both these cosine functions, they can take the value 1 when x is 0. So maximum value of this function, it will be 7 plus 5 upon 8 minus 6, which is 12 by 2, 6. So from here we'll get this condition that value of a, it must be greater than 6. Okay, the question is, let a plus b equals 4, where a is less than 2 and b should be greater than 2. And let gx be a differentiable function such that dg upon dx is greater than 0. That means dx is an increasing function. We need to prove that this integral from 0 to a gx dx plus 0 to b gx dx increases as b minus a increases. So we have to prove that this integral I, which is this integral from 0 to a gx dx plus this integral from 0 to b gx dx, it increases as b minus a increases. Now what we'll do is we'll let b minus a as t. So we need to show that di by dt is greater than 0. Now a plus b is 4 and b minus a is t. So if we add them, we can write b as t plus 4 by 2. And if we subtract, we can write a as 4 minus t by 2, where t is greater than 0. Now we'll write this integral I as this integral from 0 to 4 minus t by 2 gx dx plus this integral from 0 to 4 plus t by 2 gx dx. Now we differentiate this integral with respect to t, we can write di by dt as g 2 minus t by 2 into minus 1 by 2 and plus g 2 plus t by 2 into plus 1 by 2. Now we'll take 1 by 2 common. We can write this as g 2 plus t by 2 minus g 2 minus t by 2. Now we know that 2 plus t by 2, it is greater than 2 minus t by 2, and since g dash x is greater than 0, that means gx is an increasing function, and if gx is increasing, then g 2 plus t by 2 is greater than g 2 minus t by 2. That means this expression is greater than 0, which simply means that di by dt is greater than 0. As the value of t increases, the value of this integral also increases, and this is what we need to prove. Now here the question is, find the set of all values of parameter a for which this function fx equals sin 2x minus 8 a plus 1 sin x plus 4a square plus 8a minus 14x increases for all x belongs to R and has no critical point for all x belongs to R. Now if we find f dash x, we can write 2 cos 2x minus 8 a plus 1 cos x plus 4a square plus 8a minus 14, and it should be strictly greater than 0 for all x belongs to R. We have not taken this equality sign because it says it has no critical point. Now we can write this as 4 cos square x minus 2 minus 8 a plus 1 cos x, and here if we take 4 common, we can write this as a plus 1 whole square minus 4 minus 14, and it is greater than 0. Now we'll take these three together. We can write 4, and this is cos x minus a plus 1 whole square, and here will be 14 minus 14 18, and then minus 20, it is greater than 0. Or we can write cos x minus a plus 1 whole square, it is greater than 5. If we take square root, we can write mod of a plus 1 minus cos x, it should be greater than under root of 5. Now we'll have two separate cases. Case 1, when a plus 1 minus cos x, it is greater than under root 5, and this second case when a plus 1 minus cos x, it is less than minus under root 5. Now this is a is greater than minus 1 plus root 5 plus cos x. Now if a is greater than this entire value, it must be greater than its greatest value, and its greatest value is when the value of cos x is 1. So from here we'll get this condition that a is greater than under root 5. Now here on the left hand side it will be a is less than minus 1 minus root 5 and then plus cos x. Now if a is less than this function, it should be less than its least value, and its least value is at minus 1. So this a, it should be less than minus 2 minus root 5. So answer to this question is either a lies between minus infinite to minus root 2 minus 5, or a lies from under root 5 to infinite. Now here the question is, we are given a function f(x) which is x plus log x minus x log x for x belongs to 0 to infinite, and then we are given 3 columns. Now first question is, which of the following options is the only correct combination? Now we look at this option. Now this second one is f dash x is 0 for some x belongs to 1 to e. Now if we find f dash x will be 1 plus 1 by x minus log x and minus 1. So this f dash x is simply 1 by x minus log x. Now if we find f dash 1 is 1, and if we find f dash e is 1 by e minus log e is 1. So we can write f dash 1 into f dash e is less than 0. That means there exists a point c in the interval 1 to e such that f dash c is 0. So that means the statement second, it is correct. Now the next one is this third statement here, limit x tends to infinite f dash x. Now if we take this limit x tends to infinite, it will be 1 by x minus log x. Now 1 upon infinite is 0 and log infinite is infinite, so it approaches minus infinite. So that means this limit x tends to infinite f dash x, it is also minus infinite, so it is also correct. Now what about s? It says f dash is decreasing in e to e square. Now for that we have to find f double dash x. Now f double dash x will be minus 1 upon x square minus 1 by x. Now this is negative and this is negative, so it will be less than 0. So if second derivative is negative, that means f dash x is a decreasing function. So f dash is decreasing in a to e square. So all the three combination, second, third and s, they're correct. That means this is your option D. Now the next one is, which of the following options is the only correct combination? Now this is second, and q. Second we have already proved. Now we look at this second. Limit x tends to infinite fx. So we'll find this limit x tends to infinite fx, and this is limit x tends to infinite x plus log x minus x log x. Now what we'll do is, we let x as 1 by t. So when x tends to infinite, t tends to 0 positive. So it will be 1 by t minus log t plus log t upon t. We can write this as limit t tends to 0 positive 1 minus t log t plus log t upon t. Now we can write this as 1 plus 1 minus t log t upon t. Now this is 1 minus infinite, so it will be minus infinite upon 0, and minus infinite upon 0 is minus infinite. So as x tends to infinite, fx tends to minus infinite. Fx tends to minus infinite. That means this option 2 is correct. Now if we look at this f dash x, which is 1 by x minus log x, then we know that now this is the graph of log x and this is your 1 by x. So both these graphs, they'll intersect at only one point, which is alpha. We have already proved that this alpha, it lies in 1 comma e. So if we have any alpha which lies between 1 and e, then right hand side is negative and left hand side is positive. So here this function fx will be a decreasing function, and before alpha it will be an increasing function. Now since this alpha, it lies between 1 and e, that means between e and e square, this function fx, it is a decreasing function. That means this q is correct. So the correct options are second, and q, and that's your option D. And finally, it is talking about the only incorrect combination, and this is 3, 1 and r. So we look at 3, 1 and r. Now third is f dash x is 0 for some 0 to 1. Now we have already proved that f dash x is 0 only at one point alpha, and that point it lies between 1 and e. So it cannot be 0 between 0 and 1. So this is incorrect. Now limit x tends to infinite fx is 0. We have already proved that limit x tends to infinite fx is minus infinite. So it cannot be 0. So this first is also incorrect. And the third one is f dash is increasing in 0 to 1. Now f double dash x is less than 0 for all x belongs to r. So this f dash x, it is a decreasing function in all the values. So that means this r is also incorrect. So the combination which is incorrect is this option D, which is 3, 1 and r. Now here the question is, let f and g be increasing and decreasing function respectively from 0 to infinite to 0 to infinite. So f is defined from 0 to infinite to 0 to infinite, and g is also defined from 0 to infinite to 0 to infinite. Now it says hx is f of gx. Then hx is, so it should be this nature of hx. Now we find h dash x will be f dash gx into g dash x. Now it says fx is increasing and gx is a decreasing function. So f dash, it is positive and g dash, it is negative. That means h dash x is less than 0, which simply means that hx is a decreasing function. Now if x is greater than or equal to 0, then hx is less than or equal to h0. Now h0 is 0. So from here we get this condition that hx is always less than or equal to 0. Now this hx, it is composition of f of gx. So this hx will be defined from 0 to infinite to 0 to infinite. So its codomain will be from 0 to infinite. So this hx, it cannot take a negative value. So from this, the only possible value of hx is simply 0. So this hx will be a constant function whose value is always 0. So answer to this question is a, always 0. Now here the question is, find possible values of a such that this function fx, which is e to the power 2x minus a plus 1 e to the power x plus 2x is strictly increasing for x belongs to R. Now we find f dash x will be 2 into e to the power 2x minus a plus 1 e to the power x plus 2. Now if we let e to the power x as y, then we can write f dash y equals 2y square minus a plus 1y plus 2, and it should be greater than or equal to 0 for all y greater than 0, because e to the power x, it is always greater than 0, which simply means that this quadratic expression must be positive when y is greater than 0. So here we'll have two conditions. Either it is always positive, which is when the value of d is less than 0, or when both the roots of the equation, they are less than 0, they are negative. So if we look at this first condition will be d is less than 0, and we can also include this equality sign, because if at one point derivative is 0 and not in an interval, still that function is strictly increasing. So we can write d is less than or equal to 0. So we'll get this condition that a plus 1 whole square minus 16, it is less than or equal to 0. So it will be a plus 5, a minus 3 will be less than or equal to 0. So this is minus 5, 3 plus minus and plus. So condition will be value of a should lie between minus 5 and 3. Now for the second case, when both the roots are less than or equal to 0, we'll have this condition that d is greater than 0, sum is less than 0, and product is greater than or equal to 0. Now d is less than 0 means either the value of a is less than minus 5 or it is greater than plus 3. Now what is the sum? Sum is minus b upon a, which is a plus 1 by 2, and it is less than 0. That is value of a is less than minus 1 and product is 1. It is greater than or equal to 0. So from here we are getting this condition that a is less than minus 5. So if we take union of both the conditions, the value of a that we get is that a lies in minus infinite to 3 with 3 included. Now here the question is, we are given a function fx which is x cube minus 9x square plus 15x plus 6 for x lying between 1 and 6, and we have defined this function gx in terms of fx. It is minimum of ft when t lies between 1 to x and x lies between 1 to 6, and it is x minus 18 for x greater than 6. Now first we will draw an approximate graph of fx. Now f dash x will be 3x square minus 18x plus 15. So if we take 3 common, we can write x square minus 6x plus 5. So it will be 3x minus 1, x minus 5. So critical points are 1 and 5. Now if we find the value at 1, value at 1 will be 1 minus 9 plus 15 plus 6 22. 22 minus 9 is 13. And if we find value at 5 is 125 minus 9 into 25 plus 75 plus 6, and this value is minus 19, and value at 6 is minus 12. Now if we draw an approximate graph, now this is 0, this is 1, 5, and this is 6. There is a maxima at 1, at 13, minima at 5, at minus 19, and the value at 6 is minus 12. So if we draw this graph, there's the approximate graph of this function fx between 1 and 6. Now we have defined this function gx as minimum of ft when t lies between 1 and x. So if we choose any point x, then in the interval 1 to x, gx takes the minimum value of fx. Now in 1 to x, minimum value of this function is at this point itself. So in this case, value of gx will be same as fx. Now if we choose this x here, again in this interval, minimum value of fx is at x. So here also gx equals fx. So this gx will be equal to fx till this function is decreasing. That means between 1 and 5, gx is same as fx. So gx is same as fx. Now between 5 and 6, if we choose a point x, then its minimum value, it is no longer at x, but it is at 5. So between 5 and 6, it will be a constant function whose value is minus 19. So that's your function gx. So we can write this gx as fx, which is x cubed minus 9x squared plus 15x plus 6. When x lies between 1 and 5, it will be minus 19 when x lies between 5 and 6, and it will be x minus 18 when x is greater than 6. If we put x as 6, this value will be minus 12. So it will start from minus 12 and then it will go like this. So this is x minus 18. So it will be x minus 18 when x is greater than 6. Now first we need to prove that gx is differentiable at x equals 1. Now at x equals 1, g1, it is equal to g1 positive. So it is right continuous at 1. Now at 1, there is a local maxima. So g-1 positive, it is defined and it is equal to 0. So this gx is differentiable at x equals 1. Now second part is gx is discontinuous at x equals 6. At 6 negative, value is minus 19. At 6 positive, value is minus 12. So this function is discontinuous at x equals 6. Now it says gx is continuous and differentiable at x equals 5. Now at x equal to 5, clearly gx is continuous. And if we look at its left derivative, we know that there is a minima at this point. So g-5 negative, it is 0, and on the right hand side, it's a constant function. So g-5 positive, it is also 0. So this function is continuous and differentiable at x equals 5. And finally, we need to prove that gx is monotonic in 1 to 5. Now in between 1 to 5, this function is strictly decreasing. So it is monotonic in 1 to 5. Now here the question is, find the value of a for which this function increases throughout this number line. Now we can write f dash x as cos x minus 2a cos 2x minus 1 by 3 into 3 cos 3x plus 2a, and it should be greater than or equal to 0. Now here 3 and 3 will cancel. Now if we use cos c minus cos d, we can write 2 sin c plus d by 2. So it will be sin 2x into sin x. And here if we take 2a common, it will be 1 minus cos 2x, which is nothing but 2 sine square x and it will be greater than or equal to 0. Now here we'll take 4 sine square x common. If we take 4 sine square x, we'll get cos x plus a and it is greater than or equal to 0. Now 4 sine square x, it is always greater than or equal to 0. That means the condition that we'll get here is cos x plus a is greater than or equal to 0, or a is greater than or equal to minus cos x. Now if a is greater than this function for all the values of x, then a must be greater than its greatest value, and its greatest value is 1. So from here we'll get this condition that a is greater than or equal to 1. So this function, it will increase throughout the number line if a is 1 or greater than 1. Now here the question is, let fx equals 1 minus x cube. Then we need to find all real values of x satisfying the inequality 1 minus fx minus f cube x, and it is greater than f 1 minus fx. Now if we look at this right hand side, it is 1 minus fx minus fx cube, which is nothing but it is f of fx. So we can write f of fx, it is greater than f of 1 minus 5x. Now if we look at nature of fx, then we can find f dash x as minus 1 minus 3x square and it is less than 0, which simply means that this function f is strictly decreasing. And if f is strictly decreasing, then if we cancel this f with f, sign of inequality will reverse. So we write fx is less than 1 minus 5x. Now fx is 1 minus x cube, and it is less than 1 minus 5x. Now this 1 and 1 will cancel. So we write x cube minus 4x is greater than 0, and this is x plus 2, x minus 2 is greater than 0. So we can write minus 2, 0 and 2. So this is plus, minus, plus and minus. So this inequality is valid for minus 2 to 0 union 2 to infinite. Now here the question is, let f be a real valued function defined on the interval 0 to infinite, and it is defined as fx equals log x plus from 0 to x integral 1 plus sin t dt. Now which of the following statement is or are true? Now first we will find f dash x. Now f dash x in this case will be 1 by x plus under root of 1 plus sin x, and then derivative of x is 1. Now if we look at option B, it says f dash x exists for all x greater than 0. So if x is greater than 0, this is continuous and differentiable, and under root of 1 plus sin x is also continuous and differentiable. That means this f dash x, it exists for all x belongs to 0 to infinite. Now f dash x is also continuous on 0 to infinite. So that means these two parts are true. But what about second derivative? Second derivative will be minus 1 upon x square and then plus 1 upon 2 under root 1 plus sin x, and then derivative of sin x is cos x. Now when we have this expression in the denominator, wherever sin x is minus 1, this f dash x, it won't exist at all those points. That means at all points when the value of x is 2n pi plus 3 pi by 2, this second derivative won't be defined. So that means it is not differentiable on 0 to infinite. So this option B, it is correct. And this f double dash x, it doesn't exist for all the values from 0 to infinite. So that means option A is incorrect. Now what about option C? It says there exists some alpha greater than 1 such that mod of f dash x is less than mod fx for all x belongs to alpha to infinite. Now if we look at mod of f dash x, we can write this as 1 by x plus under root of 1 plus sin x. Now when x is greater than 1, 1 by x is less than 1, and under root of 1 plus sine x is always less than or equal to root 2. So we can say mod of f dash x, it will be less than 1 plus root 2. Now, if we look at this f dash x, this is positive and this is positive. It clearly means that this function fx is an increasing function. So if this function increases at infinite, this value will be log infinite, which is infinite. So this function, it increases and it goes all the way up to infinity. So there will be certain point alpha where the value of f alpha, it will be greater than 1 plus root 2, and thereafter for all the points this value will always be greater than 1 plus root 2. So there exists alpha greater than 1 such that mod of f dash x is less than mod fx for all x belongs to alpha to infinite. So that means option C is also correct. Option D is there exists beta such that mod fx plus mod f dash x is less than or equal to beta for all x belongs to 0 to infinite. Now we have already seen that this mod fx is unbounded as it takes the value infinite, and if mod fx is unbounded then it cannot be less than or equal to some beta. So that means this option D is incorrect. So the correct options are option B and C. Now here the question is, the function gx equals log pi plus x upon log e plus x is. Now we'll find g dash x. G dash x will be log e plus x into 1 upon pi plus x minus log pi plus x into 1 upon e plus x upon log e plus x whole square when x is greater than or equal to 0. Now we can write this g dash x as e plus x log e plus x minus pi plus x log pi plus x upon pi plus x into e plus x log e plus x whole square. Now pi plus x is positive, e plus x is positive, and this square is also positive for x greater than or equal to 0. Now for this numerator, what we'll do is we'll assume a function hx, which is x into log x when x is greater than 0, and we'll find where this function is increasing or decreasing. If we find h dash x will be 1 into log x plus 1, and it is equal to 0. Now critical point is 1 upon e, so this is plus and this is minus. When x is greater than 1 upon e, this function hx is an increasing function. Now we know that e is greater than 1 upon e and it is less than pi. We can write e plus x, it is less than pi plus x. Now in this interval, hx is an increasing function. So we can write h e plus x is less than h pi plus x, that is e plus x log e plus x is less than pi plus x log pi plus x when x is greater than or equal to 0. Now it simply means that this numerator in gx, it is less than 0. That means this gx is a decreasing function. So this gx is decreasing on 0 to infinite, and that's your option B. Now here the question is, if f dash sin x is less than 0 and f double dash sin x is greater than 0 when x lies between 0 to pi by 2 and gx is f sin x plus f cos x, then which of the following is true in 0 to pi by 2? Now if we find f dash sin x into cos x plus f dash cos x into minus sin x. Now we need to find nature of g dash x. So we have to differentiate this function once again. So we'll find g double dash x. So it will be f double dash sin x and it will be cos square x and then minus f dash sin x into sin x plus f double dash cos x into sin square x and then minus f dash cos x into cos x. Now if we substitute x as pi by 2 minus t, then we'll get f dash cos x is less than 0 and f double dash cos x is greater than 0. So we can write f dash cos x as less than 0 and f double dash cos x as greater than 0. Now f double dash sin x, it is positive, cos square x is positive, f dash sin x, it is negative. So minus and minus, it is plus, f double dash cos x positive, sin square x positive, and f dash cos x is again negative. So from here we are getting this condition that g double dash x is greater than 0. That means g dash x is an increasing function, and that's your option A. Now what about this function gx? Now if we look at this g dash x, we know that f dash sin x into cos x minus f dash cos x into sin x will be 0 if we take x as pi by 4. So that means there is a critical point at pi by 4. Now g double dash x, it is positive. That means it is always opening upwards. So at pi by 4, there is a point of local minima. So this function, it is decreasing in 0 to pi by 4 and increasing in pi by 4 to pi by 2, which is this option D, none of these. Now here the question is, consider a polynomial fx equals 1 plus 2x plus 3x square plus 4x cube, and let s be sum of all distinct real roots of fx and let t equals mod of s. Now if we differentiate this function, we can find f dash x as 2 plus 6x plus 12x square. Now for this quadratic expression, value of d is 36 minus 96, which is less than 0. Now a is greater than 0 and d is less than 0. It simply means that this quadratic is always positive. That means f dash x is greater than 0, which simply means that this function fx is strictly decreasing. And since it is a cubic function, it starts from minus infinite and it ends at plus infinite. So this curve, it will intersect x-axis only at one point. This equation will have only one real root. Now first we'll find location of this root using Bolzano's theorem. Now what we'll do is we'll find f minus 1 by 2. F minus 1 by 2 will be 1 minus 1 plus 3 by 4 and minus 2 by 4, which is 1 by 4 and it is greater than 0. And we'll also find f minus 3 by 4. Now f minus 3 by 4 will be 1 minus 3 by 2, 27 by 16 plus 4 minus 27 by 64. Now this is 16, will cancel. Now this value is minus 1 by 2. From here we can say f minus 1 by 2 into f minus 3 by 4, it is less than 0. That means at least one root of this equation will lie between minus 3 by 4 and minus 1 by 2 using Bolzano's theorem. Now since it is strictly increasing function, this equation has exactly one real root, and that real root, it will lie between minus 3 by 4 and minus 1 by 2. And now since there is only one real root, sum of roots is nothing but it'll be simply alpha. So this S, it also belongs to minus 3 by 4 and minus 1 by 2, and that's your option C. Now it says T is mod S. So that means T belongs to 1 by 2 and 3 by 4. So T, it will lie in this interval between 1 by 2 and 3 by 4. Now we find area bounded by this curve and x equals T. It will be this area. So this area, say A, it is greater than this area between 0 to 1 by 2 y dx, and it will be less than this area from 0 to 3 by 4 y dx. Now y in this case is 1 plus 2x plus 3x square plus 4x cube. So it is 1 plus 2x plus 3x square plus 4x cube. So if we integrate this function, we can write this as x plus x square plus x cube plus x to the power 4 from 0 to 1 by 2 is less than a. It is less than x plus x square plus x cube plus x to the power 4 from 0 to 3 by 4. Now this is nothing but a GP. So we can write sum of this GP as a 1 minus x to the power 4 upon 1 minus x from 0 to 1 by 2. It is less than a, and here will be x 1 minus x to the power 4 upon 1 minus x from 0 to 3 by 4. Now if we put the value, we'll get this as 1 by 2, 1 minus 1 by 16, and this is 1 by 2 is less than a, and here it is 3 by 4, 1 minus 81 by 256 upon 1 by 4. This 1 by 4 and this 1 by 2 will cancel. So this area, it will lie between 15 by 16 and 175 by 256. So this is nearly 2.05, and 15 by 16 is nearly 0.94. So you have to choose the value which contains 0.94 and 2 point this value, and that's your option A. And finally it says function f dash x increases or decreases in which interval. Now if we find f dash x will be 2 plus 6x plus 12x square, and if we find f double dash x, it will be 6 plus 24x. Now here critical point is minus 1 by 4. So it is plus and it is minus. So f dash x will be increasing in this interval and decreasing in this other interval. Now we know that value of s lies between minus 3 by 4 and minus 1 by 2. So this minus t, it will lie somewhere here, and plus t, it will lie here. So this f dash x, it will decrease from minus t to minus 1 by 4, and it will increase from minus 1 by 4 to t, and which is your option B. So the correct options are C, A and B. GU equals 2 tan inverse e to the power u minus pi by 2. Now we need to find if it is even or odd, or it is increasing or decreasing. Now if we find g minus u, it is 2 into tan inverse e to the power minus u minus pi by 2. We can also write this as 2 tan inverse 1 upon e to the power u minus pi by 2. Now when x is greater than 0, tan inverse 1 by x is cot inverse of x. So we can write this as 2 cot inverse e to the power u minus pi by 2. Now we also know that cot inverse x is pi by 2 minus tan inverse x. So it will be 2 times pi by 2 minus tan inverse e to the power u minus pi by 2. So it will be pi by 2 minus 2 tan inverse EU, which is nothing but minus GU. That means this function gx, it is an odd function. Now if we differentiate this function, we can write g dash us 2 upon 1 plus e to the power 2u into e to the power u, and it is greater than 0. So that means gx is strictly increasing. So this function is strictly increasing, and here the question is find the value of x greater than 1 for which this function is increasing and decreasing. Now we'll differentiate this function. We'll find f dash x. So we'll put upper limit in place of t and then derivative of upper limit. So it'll be 1 upon x square into log x square minus 1 by 32 into 2x minus, now we'll put lower limit. So it'll be 1 by x log x minus 1 by 32 into derivative of x is 1. Now here x and x will cancel. We'll take 1 by x common. So we'll write f dash x as 1 by x, and then this is 2 log x. So it'll be log x square. So we can write this as log x square minus 1 upon 32 whole square, and then minus log this value. Log m minus n is log m by n. So it'll be 32 by x minus 1. So we can write this f dash x as 1 by x and then log. Now this one will be x plus 1 square into x minus 1 square, and this x minus 1 will cancel once. So it will be x minus 1 upon 32. Now first we need to find critical points. Now since in the question it says x is greater than 1, this 1 upon x, it is always positive. So we need to find critical points for this expression. So if we put it equals to 0, we'll get log this value is 0, then x plus 1 square into x minus 1 upon 32, and it is equal to 1. Now we can write this as x plus 1 and then a plus b, a minus b. X square minus 1 equals 32, and it will be x cube plus x square minus x minus 1 equals 32, and this cubic equation will be x cube plus x square minus x minus 33 equals 0. Now if we put x as 3, we'll get this as 27 plus 9 minus 3 minus 33. So it will be 36 minus 36, which is 0. So one of the root of this cubic equation is x equals 3. Now we'll use synthetic division. So it will be 3, and then here the coefficients are 1, 1, minus 1 and minus 33. Now this one will be 0. So this is 1. Then 3 into 1 is 3. It will be 4. 4 into 3 is 12. So it will be 11, and 11 to 3 is 33. Now it will be 0. So we can factorize this as x minus 3 into x square plus 4x plus 11 equals 0. Now for this quadratic expression, value of d is 16 minus 40, which is less than 0. So it means it is always positive and it has no real roots. So the only critical point in this case will be when the value of x is 3. Now what about sign of the rightmost? If we take any value greater than 3, this value in the numerator will be greater than 32. So rightmost is plus and this is minus. And it's given that x is greater than 1. Now in the interval 1 and 3, this function is a decreasing function. From 3 to infinite, it is an increasing function. So this function, it decreases in 1, 3, increases in 3 to infinite. Now here the question is, we are given this function fx, which is this integral from x square to x square plus 1 e to the power minus t square dt. Then it says fx increases in which interval? Now if we find f dash x, it'll be e to the power minus x square plus 1 whole square into derivative of upper limit, which is 2x, and then minus e to the power minus x to the power 4 into derivative of lower limit, which again is 2x. So we can write this as e to the power minus x to the power 4 plus 1 plus 2x square minus e to the power minus x to the power 4 into 2x. Now what we'll do is we'll take e to the power minus x to the power 4 common. So we'll get e to the power minus x to the power 4 into e to the power minus 1 plus 2x square minus 1 into 2x. Now this e to the power minus x to the power 4, it is always positive. Now what about this one? We can write 1 plus 2x square, it is always greater than or equal to 1, or minus 1 plus 2x square is always less than or equal to minus 1. We can write e to the power minus 1 plus 2x square, it will be less than e to the power minus 1, which is 1 upon e. Now we subtract 1 from it, e to the power minus 1 plus 2x square minus 1, it is less than or equal to 1 upon e minus 1, and 1 upon e minus 1 is less than 0. So this expression, it is always negative. So everything depends on x. So the critical point here is 0. Now rightmost, this is plus. So it will be plus minus plus. So it will be minus, and then before 0, it will be plus. So this function, it increases in minus infinite to 0, and that's your option D. Now here the question is, find the set of values of a for which this function increases at every point in its domain. Now if we find f dash x will be 1 minus under root of 21 minus 4a minus a square upon a plus 1 into 3x square plus 5. Now this is positive, 3x square is also positive. So this function will be increasing always, increasing at every point if it is greater than or equal to 0. So the condition that we are getting here is 1 minus under root of 21 minus 4a minus a square upon a plus 1 is greater than or equal to 0, or under root of 21 minus 4a minus a square upon a plus 1, it is less than or equal to 1. Now we need to solve this inequality. Now first we'll find its domain. Its domain is 21 minus 4a minus a square. It should be greater than or equal to 0, or a square plus 4a minus 21 is less than or equal to 0, which is a plus 7, a minus 3 is less than or equal to 0. That is, value of a should lie between minus 7 and 3, and also a cannot take the value minus 1. So this is the restriction of domain. Now we'll take two separate cases. Case 1, when a plus 1 is less than 0. So if a plus 1 is less than 0, in that case, this is positive and this is negative. So this left hand side is negative and right hand side is positive, which is true for all the values of a. That is, we get this solution that a is less than minus 1. Now for the second case, when a plus 1 is greater than 0, that is, when a is greater than minus 1, both the expressions, they are positive. So if we cross multiply, we can write 21 minus 4a minus a square, it is less than or equal to a plus 1. Now if we square it, we can write 21 minus 4a minus a square, it is less than or equal to a square plus 1 plus 2a, or 2a square plus 6a minus 20 is greater than or equal to 0, or a square plus 3a minus 10 is greater than or equal to 0. Now this is a plus 5, a minus 2, it is greater than or equal to 0. So the condition is minus 5 to plus minus and plus. So either a is less than or equal to minus 5 or a is greater than or equal to 2. But we get this result from the condition that a is greater than minus 1. So this a, it must be greater than minus 1. So from here we will get this condition that a is greater than or equal to 2. So we have three conditions. Either a is less than minus 1 or a is greater than or equal to 2, and a should lie between minus 7 and 3 excluding minus 1. Now we'll find which all values of a satisfy these three conditions. Now this is OR. So this is either a is less than minus 1 or a is greater than or equal to 2, and this is the value of a should lie between minus 7 and 3. So it will be from minus 7 to 3, both inclusive except minus 1. So the values of a which are common to all the conditions are a belongs to included minus 7 to not included minus 1 union included 2 to included 3. Now here the question is, find the intervals of increase of gx where gx is 2f x square by 2 plus f 6 minus x square, and it is given that f double dash x is greater than 0, which means f dash x is an increasing function. Now we differentiate this function, we can write g dash x as 2f dash x square by 2 into 2x by 2 and plus f dash 6 minus x square into minus 2x. Now this 2 and 2 will cancel. We'll take 2x common. We'll get f dash x square by 2 minus f dash 6 minus x square. Now we need to find intervals of increase of gx. That means this g dash x, it must be greater than 0. Now we'll take two cases. Case 1, when this is positive and this is positive. That is when x is greater than 0 and f dash x square by 2, it is greater than f dash 6 minus x square. Now since f dash is an increasing function, so if we cancel f dash, sign of inequality, it won't change. So we'll get x square will be greater than 12 minus 2x square, or x square is greater than 4, or mod of x is greater than 2. Now since x is greater than 0, the only condition that we get from here is x belongs to 2 to infinite. Now when x is less than 0, this is negative, then it must also be negative. So we'll get this condition that f dash x square by 2, it must be less than f dash 6 minus x square. We'll get this condition that x square is less than 4, that is mod x is less than 2. And since x is less than 0, so we'll get this condition that x belongs to minus 2 to 0. So we are getting two conditions. Either x is greater than 2 or x lies between minus 2 and 0. Now here the question is, we are given a function fx which is 1 minus x whole square into sine square x plus x square for all x belongs to R. And we are given this function gx, which is defined as this integral from 1 to x to t minus 1 upon t plus 1 minus log t ft dt, where x belongs to 1 to infinite. Now the first question is, consider the two statements P. There exists some x belongs to R such that fx plus 2x equals 2 1 plus x square. And second one is, there exists some x such that 2fx plus 1 equals 2x into 1 plus x. Now first we look at the statement P. Now statement P, it says fx plus 2x, it is equal to 2 plus 2x square. Now we'll put the value of fx, so it will be 1 minus x square into sine square x plus x square plus 2x, and it will be 2 plus 2x square. So we can write this as 1 minus x square into sine square x, and it will be x square minus 2x plus 2. We'll add 1 and subtract 1. We can write 1 minus x square sine square x, and it will be 1 minus x whole square plus 1. Now we'll take 1 minus x square here, so we'll write 1 minus x whole square, and then 1 minus sine square x will be cos square x, and this value will be equal to minus 1. Now since this is square of some number, it is always greater than or equal to 0, and it can never be equal to minus 1. So that means the statement P is incorrect. So statement P is false. Now what about statement Q? Statement Q says there exists some x belongs to R such that 2fx plus 1 equals 2x into 1 plus x. So here what we'll do is we'll define a function, say hx, which is given by 2fx plus 1 minus 2x minus 2x square. So we'll write this as hx equals 2, and then what is fx? Fx is 1 minus x whole square into sine square x plus x square, and then 1 minus 2x minus 2x square. So this hx function will be 2 into 1 minus x whole square into sine square x, and then plus 1 minus 2x minus x square. Now this hx is a continuous function. If we find h0, then h0 will be 1, and if we find h1, h1 will be, this is 0, and here it will be minus 2. So h0 is positive and h1 is negative. So this function, it will cross this x-axis between 0 and 1 at least 1. So that means there is at least 1x in the interval 0 to 1 where hx is 0. That means this statement Q, it is correct. So we'll have some x in R such that this equation is valid. So answer to this question is P is false and Q is true, and that's your option C. Now the second part is we need to find if gx is increasing or decreasing. So we'll find g dash x. G dash x will be 2 x minus 1 upon x plus 1 minus log x, and derivative of x is 1 minus derivative of 1 is 0 into fx. Derivative of x is 1 minus lower limit. Lower limit is constant, so its derivative will be 0. So we can write g dash x as 2. Now we'll add 1 and subtract 1. So we'll write 2 minus 4 upon x plus 1 minus log x into fx. Now fx, it is sum of squares. So this fx is always greater than or equal to 0. Now what about this expression? 2 minus 4x plus 1 minus log x. We'll take this as some function, say 5x, 2 minus 4 upon x plus 1 minus log x when x is greater than 1. Now we'll find 5 dash x. So it will be 4 upon x plus 1 square minus 1 by x. So it will be 4x minus x square minus 1 minus 2x upon x into x plus 1 square. So it will be minus x minus 1 whole square x upon x plus 1 square, which is always less than 0. That means this phi x, it is decreasing function. So if x is greater than 1, and since phi x is decreasing, phi x is less than phi 1. So we'll write phi x and will be less than phi 1. What is phi 1? Phi 1 is 2 minus 2, which is 0. That means this phi x is always less than 0. So this expression is always negative. So this g dash x, it is less than 0 for all x greater than 1. So this function gx, it is always decreasing in 1 to infinite, and that's your option B. Now here the question is, let b be a non-zero real number and let f be a differentiable function such that f0 is 1 and derivative of fx is equal to fx upon b square plus x square. Then which of the following statements is or are true? Now we can write f dash x upon fx, it is equal to 1 upon b square plus x square. Now if we integrate both sides, we can write log fx will be equal to 1 upon b tan inverse x upon b and plus c. Now we are given initial condition that when x is 0, y is 1. So log 1 is 0 and tan 0 is 0. So from here we can write c is 0. Now we can write this function fx as e to the power 1 upon b tan inverse x upon b. Now this fx, it is greater than 0. So if we look at this f dash x, it will be e to the power 1 upon b tan inverse x upon b square plus x square, which is greater than 0 for all x belongs to R. So for all values of b, this function, it is an increasing function. So which is your option A. Now if we look at f minus x will be e to the power tan inverse minus x, and tan inverse of minus x is minus tan inverse x, will be minus 1 by b tan inverse x upon b. Now if we multiply them, we can write fx into f minus x, which is e to the power 0 and it is 1. So fx into f minus x will be 1 for all x belongs to R. So answer to this question is options A and C. Now here the question is, construct the graph of function fx equals minus x square minus 9 upon x plus 3 minus x plus 2 upon x minus 1. Now x cannot be minus 3 and x cannot take the value 1. Now if x is unequal to minus 3, we can write this as a plus b, a minus b. So we can write fx as minus, now this is x minus 3 minus x plus 2 upon x minus 1. Now this x and x will cancel. We can write this fx as minus mod of 2x minus 1 minus 3. Now we'll draw its graph. We'll start with the basic graph, which is y equals 2 by x, which is standard rectangular hyperbola. Now we'll draw the graph of y equals 2 upon x minus 1. We'll shift the entire graph plus 1 units. So this is 1. And then we'll draw the graph of y plus 3 equals 2 upon x minus 1. So we'll shift this entire graph minus 3 units along y-axis. So now this graph will be drawn like this. Now this point of intersection, it will be when y is 0. Now if we put y as 0, we'll get 3x minus 3 equals to x is 5 by 3. So this point is 5 by 3 comma 0. Now we'll take transformation of mod fx, 2x minus 1 minus 3. Now transformation of mod fx is place a mirror on x-axis and take the reflection of down on up. So if we take this reflection, we can draw this graph as this is 5 by 3. This is 1. This is y equals 3. And here it will be this line. And finally, we have to place a minus sign here. So the graph of f minus mod of 2 upon x minus 1 minus 3, it will be this graph. This point is 1. This is 5 by 3, and also x cannot take the value minus 3. So at minus 3, there is a missing point here. So this is the graph of this given function. Now the first question is, we need to find the range of this function. Now this function can take the values from minus infinite to 0. So range of this function is from minus infinite to included 0. Now we need to find intervals of monotonicity. Now this function, it decreases in minus infinite to 1, union 5 by 3 to infinite, and this function, it increases in 1 to 5 by 3. Here in decreasing function, we have to remove this point, so it will be minus of minus 3. Now third point is points where f is continuous but not differentiable. So this function is continuous but not differentiable at x equals 5 by 3. And finally, points where f fails to be continuous and nature of discontinuity. Now it has a removable discontinuity at x equals minus 3, and x equal to 1, it has non-removable discontinuity. And that is the answer to this question. Now here the question is, find the number of real roots of the equation fx equals a1 square upon x minus b1 plus a2 square upon x minus b2 plus a3 square upon x minus b3 up to an square upon x minus bn minus c. Now x is not defined at b1, b2 and bn. So for the graph of fx, there will be vertical asymptotes at b1, b2, b3 and bn. And it is given that b1 is less than b2 and it is less than bn. Now if we take this limit x tends to infinite fx, all these expressions, they will be 0. So this is minus c, and also limit x tends to minus infinite fx, it is also minus c. So there is a horizontal asymptote at y equals minus c. So suppose this is y equals minus c. Now if we differentiate this function, we can find f dash x as minus a1 square upon x minus b1 square minus a2 square upon x minus b2 square and minus an square upon x minus bn square, which is always less than 0. So this function fx is a decreasing function. So this function fx, it decreases. So it'll start with minus c and then it'll decrease. Here again it'll decrease. Here again it will decrease. So it will decrease in all the intervals, and finally will be drawn like this. Now we need to find number of real roots of this equation. So we'll have three separate cases. Case 1, when c is 0. If c is 0, then in that case this line itself is x-axis. So in this case there will be n minus 1 roots. And second case, if c is greater than 0. If c is greater than 0, in that case x-axis it'll be drawn above this line. There we'll have n roots, and if c is less than 0, then x-axis will be below this line. Again, it'll have n roots. So this equation will have n minus 1 roots if c is equal to 0, and it'll have n roots if c is negative or c is positive. Now here the question is, if f is defined on 0 to 1 to r, and suppose this f is twice differentiable such that f0 equals f1 equals 0, and it satisfies f double dash x minus 2 f dash x plus fx, and is greater than or equal to e to the power x for x belongs to 0 to 1, then which of the following is true for x lying between 0 and 1? Now we can write this as e to the power minus x into f double dash x minus e to the power minus x into f dash x, and then minus e to the power minus x into f dash x minus e to the power minus x into fx, and it is greater than or equal to 0. This is d by dx of e to the power minus x into f dash x, and this is derivative of e to the power minus x into fx, and it is greater than or equal to 0. Now we can write this as d by dx of e to the power minus x into f dash x minus e to the power minus x into fx, and it is greater than or equal to 0. Now this again is derivative of e to the power x fx. We can write d square by dx square e to the power minus x into fx, it is greater than or equal to 0. So if we take this as some function gx, then we get this condition that g double dash x is greater than or equal to 0. That is, this function gx is concave up. So now we are given that this function is defined between 0 and 1. Value at 0 is 0 and value at 1 is also 0, and in between 0 and 1 this function is concave up, which means that this fx, it must be less than 0, and that's your option D. Now its second part is, if e to the power minus x into fx, assume its minimum value in the interval 1 to 4 at 1 by 4, then which of the following is true? Now we have already proved that in between 0 and 1 this function is concave down. Now it says its point of minima is 1 by 4. So this is how it will be drawn. Now gx in this case is e to the power minus x into fx. Now if we write g dash x will be e to the power minus x into f dash x minus e to the power minus x into fx. Now when x lies between 0 to 1 by 4, gx is a decreasing function. So that means g dash x is less than 0. So from here we write f dash x will be less than fx. So the condition that we'll get is f dash x will be less than fx when x lies between 0 and 1 by 4, and that's your option C. Now question number 27, it's a wonderful question. It says this function fx is defined as maximum of mod x minus y upon x plus y plus 1 when y lies between 0 and 1 for x lying between 0 and 1. So for this function, I'll consider this first case when y is less than or equal to x. So in that case, I can write this function as some function g as a function of y, which is, now since y is less than x, I can simply write it as x minus y upon x plus y plus 1. Now in this range from 0 to x, I'll need to find maximum value of this function. So what I'll do is I'll differentiate this function. So I'll find g dash y. So it'll be x plus y plus 1 and then minus 1 and minus x minus y upon x plus y plus 1 whole square. So in this case, I'll get minus 2x minus 1 upon x plus y plus 1 whole square, which is less than 0. So that means in this interval from 0 to x, this function gxy, it is a decreasing function. Now, if the function is a decreasing function, then the maximum value of this function occurs at starting of this interval. So that means maximum value of gxy is equal to gx when y is 0. So if I'll put y as 0, I'll get this function as x upon x plus 1. Now I'll take the second case. Now the second case when x is less than y and this is less than equal to 1. Now in that case, this function of y, it is given as, now here since y is greater than x, so I'll write it as y minus x upon x plus y plus 1. Now if I'll differentiate, I'll get x plus y plus 1 minus y minus x upon x plus y plus 1 whole square. So here will be 2x plus 1 upon x plus y plus 1 whole square, which is greater than 0. So that means in this interval, this function, it will be an increasing function. Now if the function increases, then the maximum value of this function occurs at end of this interval. So that means in this case, maximum value of gxy will occur at y equals 1. If we'll put y as 1, we'll get this as 1 minus x upon x plus 2. So I can write this function fx as x upon x plus 1 when x lies between 0 and a, and this is 1 minus x upon x plus 2 when x lies between a and 1. Now how do I find this a? Now we know that this fx, it always takes maximum value. So there'll be this point a where the value of this first function must be equal to the value of this second function. So that means at x equal to a, this a upon a plus 1 must be equal to 1 minus a upon a plus 2. Now if I'll solve this condition, I'll write a square plus 2a is equal to a plus 1 minus a square minus a. So I'll get it as 2a square plus 2a minus 1 equals to 0. Then the value of a is minus 2 plus minus, and this is 4 plus 8 upon 4. So it will be minus 1 plus minus under root 3 by 2. Now this a, it must lie between 0 and 1. So that means the value of a possible in this case is minus 1 plus root 3 upon 2. So that means this function fx is defined as x upon x plus 1 when the value of x lies between 0 and root 3 minus 1 upon 2, and this function is 1 minus x upon x plus 2 when the value of x lies between root 3 minus 1 upon 2. Now we need to find where this function increases and where this function decreases. So I'll differentiate this function. So if I'll differentiate this function, I can write f dash x as x plus 1 minus x upon x plus 1 whole square, which is 1 upon x plus 1 whole square when x lies between 0 and root 3 minus 1 by 2. And if I'll differentiate the other one, I'll write x plus 2 whole square, x plus 2 into minus 1, and then minus 1 minus x, which is minus 3 upon x plus 2 whole square when x lies between root 3 minus 1 upon 2 and 1. So which means when x lies in this interval, this derivative is always positive, and the other interval, this derivative is always negative. So that means this function is strictly increasing on 0 to root 3 minus 1 upon 2 and strictly decreasing on root 3 minus 1 upon 2 and 1. So that means answer to this question is option number C. Today we'll be discussing some selected problems in application of derivatives. We'll include problems from tangent and normals, monotonicity, maximum minima, curve tracing, and also rate measure. Now the first question is, find the equation of straight line which is a tangent at one point and normal at another point to the curve y equals 8t cube minus 1 and x equals 4t square plus 3. So we have a curve and it says tangent at one place, say this point which is A, and it is represented by t1. It is normal at another point B, which is say t2. Now in this case, dy by dt is 24t square and dx by dt is 8t. So from here we can say dy by dx is 3t. Now slope of tangent at this point A, it is 3t1. Now slope of normal is minus dx upon dy. So slope of normal at B is minus 1 upon 3t2. And since we are talking about the same straight line, so we'll get this condition that 3t1, it must be equal to minus 1 upon 3t2 and will be equal to slope of this line, which is y2 minus y1 upon x2 minus x1. Now y2 minus y1 will be 8 t2 cube minus t1 cube upon 4 t2 square minus t1 square. Now we can simplify this as 8 t2 square plus t1 square plus t1 t2 upon 4 t2 plus t1. Now this 4 and 8 will also cancel. Now if we equate these two, we'll get our first condition, and which is t1 into t2 is minus 1 by 9. And if we take this first and third, we can write 3t1 t2 plus 3t1 square will be equal to 2t2 square plus 2t1 square plus 2t1 t2. We can write this as t1 square minus 2t2 square and will be equal to minus t1 into t2. Now we can write this t2 as minus 1 by 9t1. So it will be t1 square minus 2 by 81 t1 square, and here this value, it will be 1 by 9. Now this is 81 t1 to the power 4 minus 2 upon 81 t1 square, and this value is equal to 1 by 9. So this is 9. So we can write this equation as 81 t1 to the power 4 minus 9 t1 square minus 2 equals 0. Now if we solve this quadratic equation, we'll get t1 square as minus 1 by 9 or t1 square as 2 by 9. Now minus 1 by 9, it won't give us any real solution. We'll get t1 equals plus minus under root 2 by 3. Now if we put the value of t1 in this, we can write t2 as minus plus 1 by 9 and t1 is root 2 by 3. So it will be minus plus 1 upon 3 root 2. Now once we have the value of t1 and t2, we can write equation of this line as y minus 8 into plus minus 2 root 2 upon 27 minus 1 equals 3 into plus minus root 2 upon 3 and then x minus 4 into 2 by 9 plus 3. If we simplify this equation, we'll get this equation as 27y plus 1 minus plus 16 root 2 will be equal to plus minus root 2 into 27x minus 105, and this is the equation of line that we need. So there will be two such lines. Now here the question is, the tangent to the curve y equals e to the power x drawn at a point c comma e to the power c intersects the line joining the points c minus 1 e to the power c minus 1 and c plus 1 e to the power c plus 1, then which of the following options is correct? Now if we draw the graph of e to the power x, first we'll draw the axis, and then this is our graph of y equals e to the power x. Now we have a point on this curve which is c comma e to the power c. Now we'll draw tangent to this curve at this point, and then it says we have two more points given by c plus 1. This is c plus 1 e to the power c plus 1, and then this point which is c minus 1. The point is c minus 1 e to the power c minus 1. Now if we join these 2 points, we have this line segment. Now if we extend this line, we need to find these 2 lines. They'll intersect on the left of c or on the right of c. Now what we'll do is we'll find slope of both the lines m1 and m2. Now m1 is y2 minus y1 upon x2 minus x1. So it will be e to the power c plus 1 minus e to the power c minus 1 upon c plus 1 minus c minus 1, which is e to the power c e minus 1 upon e whole divided by 2. And if we find m2, m2 is slope of tangent to this curve at this point c, which is nothing but e to the power c. Now we know that e minus 1 upon e by 2, it is greater than 1. So from here we can say this m1, it is greater than m2. If they were parallel, they'll never intersect. But in this case, since the slope of m1 is greater than slope of m2, that means distance between them will increase. So these two lines, they'll intersect on the left of c. So answer to this question is these two lines, they'll intersect on the left of x equals c, and that's your option A. Now here the question is, a straight line is drawn through the origin and parallel to tangent to this curve at an arbitrary point M. Show that the locus of point P of intersection of the straight line through origin and the straight line parallel to x-axis passing through M is. Now first what we'll do is we'll try and change this equation in terms of parametric coordinates. So we'll write this y as some a sine theta, and if we write y as a sine theta, we'll get this as x plus a cos theta upon a, and it'll be log, and this is a plus a cos theta upon a sine theta. Now here this a will cancel. We can write this x as minus a cos theta plus a log. Now this is 1 plus cos theta upon sine theta. Now if we use half angle formula, 1 plus cos theta is 2 cos square theta by 2, and sine theta is 2 sine theta by 2 into cos theta by 2. Now cos theta by 2 and 2 will cancel. So we can write this x as minus a cos theta plus a log cot theta by 2. So we'll assume this arbitrary point M as minus a cos theta plus a log cot theta by 2 and a sine theta. A straight line is drawn through origin parallel to tangent to this curve at point M. So we'll find slope of this line. We'll find dy by dx. Dy by d theta, it will be a cos theta, and dx by d theta will be a sine theta a, and this is cot theta by 2 and cosec square theta by 2 into 1 by 2, which is a sin theta, and this is minus a. Now this is 2 sin theta by 2 cos theta by 2, which is sin theta. We can write this as minus a cos square theta upon sin theta. Therefore, we can write dy by dx as now dy by d theta, which is a cos theta upon minus a cos square theta upon sin theta will be nothing but minus tan theta. Now once we have slope of this line and it passes through origin, we can write equation of this line as y equals minus tan theta x, and that's our first equation. Now it says, suppose that the locus of point P of intersection of straight line through origin and straight line parallel to x-axis passing through M. So we have the straight line passing through M and parallel to x-axis, which is given by y equals constant, and constant in this case is a sin theta. So this other straight line is y equals a sin theta, and that's our second. We need to find locus of point of intersection of these two lines. Now suppose the point of intersection is alpha comma beta. Now we can write beta equals a sin theta, and if we put the value of beta here, we can write a sin theta equals minus tan theta into alpha, or alpha equals minus a cos theta. Now we need to eliminate theta. So if we square and add them, we can write alpha square plus beta square equals a square. So locus of point of intersection will be simply x square plus y square equals a square, and this is what we need to prove. Now here the question is, if the tangent at point x1 y1 to the curve x cube plus y cube equals a cube meets the curve again in x2 y2, then show that x2 upon x1 plus y2 upon y1 equals minus 1. Now both the points, they lie on this curve, so we can write x1 cube plus y1 cube equals a cube, and x2 cube plus y2 cube equals a cube. Now it says tangent to this curve at x1 y1 intersects it at x2 y2. So first we'll find slope of tangent at this point, say P. We can write 3x square plus 3y square dy by dx, and it is equal to 0. So we find dy by dx at this point P, it will be minus x1 square upon y1 square, and it will be equal to slope of this line, which is y2 minus y1 upon x2 minus x1. So this is our first equation. Now from these two given equations, we can write x1 cube plus y1 cube, and it will be equal to x2 cube plus y2 cube, or we can write x1 cube minus x2 cube, it is equal to minus y1 cube minus y2 cube. Now if we use cubic formula, we can write x1 minus x2 into x1 square plus x2 square plus x1 x2 will be equal to minus y1 minus y2 y1 square plus y2 square plus y1 y2. Now if we rearrange it, we can write x1 square plus x2 square plus x1 x2 upon y1 square plus y2 square plus y1 y2, it is equal to minus, and then y2 minus y1 upon x2 minus x1. Now this is minus x1 square upon y1 square. So we can write this as x1 square upon y1 square. Now we'll take this x1 square on the left hand side, and we'll take this expression in the denominator on the right hand side. We can write 1 plus x2 upon x1 whole square plus x2 upon x1 will be equal to 1 plus y2 upon y1 whole square plus y2 upon y1. Now this 1 and 1 will cancel. Now what we'll also do is we'll add 1 by 4 both sides. Now we can write this as x2 upon x1 plus 1 by 2 whole square and it is equal to y2 upon y1 plus 1 by 2 whole square. Now we'll get x2 upon x1 plus 1 by 2 will be equal to plus or minus y2 upon y1 plus 1 by 2. Now if we take plus sign, we won't get distinct points. So if x1, y1 and x2, y2, they are distinct points, we'll have to choose minus sign. So we can write x2 upon x1 plus 1 by 2 minus y2 upon y1 minus 1 by 2. Now we rearrange it, we can write this as x2 upon x1 plus y2 upon y1, and it is equal to minus 1, which is what we need to prove in this question. Now the question is, the chord of parabola y square equals minus a square x square plus 5ax minus 4. It touches the curve y equals 1 upon 1 minus x at a point where the value of x is 2. Now if we put x as 2, we'll get this as minus 1. So point of contact is 2 comma minus 1. And it's bisected by this point. So this chord, it is bisected at this point. Now once we have this point and this curve, we can write equation of the straight line. So dy by dx, it will be minus 1 upon 1 minus x whole square into minus 1. And if we put x as 2, we'll get dy by dx at this point, say P, and it'll be 1. So equation of this line will be y plus 1 equals 1, x minus 2, or x minus y minus 3 equals 0. So this is the equation of this straight line. Now it is also given that this chord, it is bisected at this point. Now we know that if we have midpoint of a chord, then equation of chord is given by t equals s1 for this parabola, which is a square x square minus 5ax plus y plus 4 equals 0. Now we can write this as a square. Now x square is x into x1, so it will be 2x minus 5a x plus 2 by 2 plus y minus 1 by 2 and then plus 4, and it will be equal to 4a square minus 10a minus 1 plus 4. Now this 4 and 4 will cancel. We can write this as 4a square x minus 5ax minus 10a plus y minus 1, and it will be equal to 8a square minus 20a minus 2. Now we can write this equation as 4a square minus 5ax plus y, and it will be equal to 8a square minus 10a minus 1. Now both these equations, they represent same line. So if we compare both of them, we get 4a square minus 5a, it must be equal to minus 1, and 8a square minus 10a minus 1, it must be equal to minus 3. Now both these equations, they represent same quadratic equation, which is 4a square minus 5a plus 1 equals 0. So it will be 4a square minus 4a minus a plus 1 equals 0. So it will be 4a minus 1 into a minus 1 equals 0. So either the value of a is 1 by 4 or the value of a is 1. Now if we choose a as 1 by 4, then this given point P 2 comma minus 1, it lies outside parabola. It cannot be midpoint of the chord. So we'll discard a equals 1 by 4. So the only possible value of a in this case is a equals 1, and that is the answer to this question. Now here the question is, find the condition that these two curves, they may intersect orthogonally. Now we'll say, let their point of intersection be x1, y1. Now we differentiate this curve. We can find slope of tangent, so it will be 2x1 upon a plus 2y1 upon b into dy by dx. It is 0, so we can write m1 as minus bx1 upon ay1. And if we differentiate the second curve, we can write m2 as minus b dash x1 upon a dash y1. Now since these two curves, they are orthogonal, product of slope is minus 1. So we can write m1 into m2 is minus 1, that is b dash x1 square upon a dash y1 square, and this value is equal to minus 1, and that's our first equation. Now we have to find this condition with a and b. We need to find the value of x1 square upon y1 square. Now these two curves, they intersect at this point, x1, y1. So we can write x1 square upon a plus y1 square upon b, it is equal to 1, and it is equal to x1 square upon a dash plus y1 square upon b dash. Now we take x1 square on the same side, we'll write x1 square 1 upon a minus 1 upon a dash equals y1 square 1 upon b dash minus 1 upon b. So from here we can write x1 square upon y1 square, it will be b minus b dash upon b dash into a dash upon a dash minus a. Now we'll put the value of x1 square upon y1 square. So it will be b dash upon a dash, and this is b minus b dash into a dash minus a into b dash. Now these two, they'll cancel, and this is equal to minus 1. So we can write b minus b dash equals minus a dash plus a. So the condition is a minus b is equal to a dash minus b dash. So these two curves, they'll intersect orthogonally if a minus b is equal to a dash minus b dash. Now here the question is, show that the angle between the tangent at any point a on the curve log x square plus y square equals c tan inverse y by x, and the line joining a to the origin is independent of the position of a on the curve. Now what we'll do is, we'll let y by x equals tan theta. Then y is x tan theta, so we can write log x square plus x square tan square theta will be x square secant square theta, and this is c, and here it will be tan inverse y by x, nothing but theta. So we can write this x as e to the power c theta into cos theta, and that's our first equation. Now if we put the value of x here, we'll find y. Y will be e to the power c theta into tan theta into cos theta, which is sin theta, and that's our second equation. So let this point A be e to the power c theta cos theta comma e to the power c theta sin theta. Now it says angle between tangent at any point A and line joining A to origin, and line joining A to origin, we have to prove that this angle, it is independent of theta. Now first we will find slope of tangent at A. Now dy by d theta is e to the power c theta cos theta plus sin theta c into e to the power c theta, and dx by d theta will be e to the power c theta minus sin theta plus cos theta into c e to the power c theta. Now we divide them, we can write dy by dx as cos theta plus c sin theta upon minus sin theta plus c cos theta. So this is, say, m1. Now we'll find m2, and m2 is y minus 0 upon x minus 0. So it will be nothing but tan theta. Now we need to prove that angle between these two lines, it is independent of theta. So we'll find tan alpha. Now tan alpha is m2 minus m1 upon 1 plus m1 m2. So it will be sin theta upon cos theta minus cos theta plus c sin theta upon c cos theta minus sin theta upon 1 plus sin theta cos theta into cos theta plus c sin theta upon c cos theta minus sin theta. So we can write this as c sin theta cos theta minus sin square theta minus cos square theta minus c sin theta cos theta, which will cancel upon, now this denominator part will cancel with both. So here will be c cos square theta minus cos theta sin theta plus sin theta cos theta plus c sin square theta. Now here also sin theta cos theta will cancel. Now sin square theta plus cos square theta, it is 1, and c sin square theta plus c cos square theta is c. So this angle between these two lines is 1 by c, which is independent of theta. Here the question is, the curve y equals ax cube plus bx square plus cx plus 5 touches x-axis at this point P minus 2, 0 and cuts the y-axis at Q where its gradient is 3. Find the value of A, B and C. Now at P, it touches x-axis, which simply means that y of minus 2 is 0 and y dash minus 2 is also 0. Now at this point Q where it intersects y-axis, so at y-axis we'll put x as 0, so this point Q is 0, 5, and if we find slope of derivative, which is dy by dx, dy by dx will be 3ax square plus 2bx plus c. So dy by dx at this point Q, it will be simply c, and is given as 3. So from here we know value of c is 3. So we can write this curve as y equals ax cube plus bx square plus 3x plus 5. Now we put x as minus 2, we'll get minus 8a plus 4b and minus 1 equals to 0, and y dash minus 2 is also 0, so we'll get 12a minus 4b plus 3 equals 0. Now if we add them, we can write 4a plus 2 equals 0. So value of a is minus 1 by 2, and if we put value of a in this equation, we can write 4 plus 4b minus 1 equals 0. So value of b is minus 3 by 4. So answer to this question is value of a is minus 1 by 2, value of b is minus 3 by 4, and value of c is 3. Now here the question is, the tangent at a variable point p on the curve y equals x square minus x cube meets it again at q. Show that locus of midpoint of PQ is y equals 1 minus 9x plus 28x square minus 28x cube. Now it says tangent at a variable point P meets the curve again at Q. We need to find locus of its middle point. Now suppose this point P is h comma h square minus h cube, and this point Q is k comma k square minus k cube. Now this straight line, it is tangent at P. So if we find dy by dx will be 2x minus 3x square. Now dy by dx at this point P will be 2h minus 3h square. Now the slope of tangent, which is 2h minus 3h square, it must be equal to slope of this line segment. So it will be k square minus h square minus k cube minus h cube upon k minus h. Now this is a plus b, a minus b, and it is a minus b, a square plus b square plus ab. So we can write this as 2h minus 3h square, and it will be k plus h minus k square plus h square plus kh. Now this is 2h minus 3h square, and this is k plus h minus k square minus h square and minus kh. Now if we take everything on the right hand side, we can write 2h square minus h minus k square plus k minus hk equals 0. Now what we'll do is we'll take one h square from this and we'll take it with k square. So we can write h square minus k square, and then we'll take other h square with this. So we'll write h square minus hk, and then we'll take minus common. It'll be h minus k equals 0. Now we can write this as h minus k, and here it will be h plus k plus h minus 1 equals 0. Now h, it cannot be equal to k. So the condition that we get from this is 2h plus k minus 1 equals 0. So now we have this one relationship, which is 2h plus k equals 1. And we need to find locus of midpoint of PQ. Suppose this is alpha beta. Now alpha is h plus k by 2 and beta is h square plus k square minus h cube plus k cube whole divided by 2. Now from this we can write h plus k equals 2 alpha. Now we can solve the value of h and k. Now h in this case will be 1 minus 2 alpha, and if we put h as 1 minus 2 alpha, we'll get k as 4 alpha minus 1. Now we'll put the value of h and k in this equation to find this locus. So this locus will be beta equals 1 minus 2 alpha whole square plus 4 alpha minus 1 square minus 1 minus 2 alpha cube plus 4 alpha minus 1 cube whole divided by. Now if we solve this and if we put alpha as x and beta as y, we can write this as y equals 1 minus 9x plus 28x square minus 28x cube. And this is the answer to this question. Show that the condition that the curves x to the power 2 by 3 plus y to the power 2 by 3 equals c to the power 2 by 3 and x square upon a square plus y square upon b square equals 1 may touch. Now if these two curves, they touch each other, then at their point of contact, which is say x1 y1, slope of tangent will be same. Now we differentiate this first curve, we can write 2 by 3 x1 to the power minus 1 by 3 plus 2 by 3 y1 to the power minus 1 by 3 dy by dx, it is equal to 0. So dy by dx at this point P, it will be minus y1 to the power 1 by 3 upon x1 to the power 1 by 3. And this is our first equation. Now from this ellipse, if we differentiate it, we can write 2x1 upon a square plus 2y1 upon b square dy by dx. At this point P, it is 0. So dy by dx at this point P will be minus b square x1 upon a square y1, and that's our second equation. Now since these two curves, they touch each other, they'll have a common tangent. So slope of tangent, it must be same. So if we equate them, we can write minus y1 to the power 1 by 3 upon x1 to the power 1 by 3 will be equal to minus b square x1 upon a square y1. Now this minus and minus will cancel. We can write y1 to the power 4 by 3 upon x1 to the power 4 by 3, it is equal to b square upon a square. Now if we take cube, we can write y1 to the power 4 upon x1 to the power 4 will be equal to b to the power 6 upon a to the power 6. And if we take square root, we can write y1 square upon x1 square, it must be equal to b cube upon a cube. So from here we can say let y1 square be b cube k and x1 square be a cube k. Now this x1 y1, it will lie on this ellipse. So we can find the value of k. We can write x1 square upon a square, which is ak, plus y1 square upon b square, which is bk, and it should be equal to 1. So from here we can say value of k is 1 upon a plus b. Now this x1 y1, it will also lie on this curve. So we can write x1 to the power 2 by 3 plus y1 to the power 2 by 3, it is equal to c to the power 2 by 3. x1 to the power 2 by 3 is a into k to the power 1 by 3, and the same way y1 to the power 2 by 3 is into k to the power 1 by 3, and it is equal to c to the power 2 by 3. Now we can write this as a plus b, and what is k? K is 1 upon a plus b, so it is 1 upon a plus b to the power 1 by 3, it is equal to c to the power 2 by 3, or a plus b to the power 2 by 3, it is equal to c to the power 2 by 3. So from here we can say the value of a plus b, it must be equal to c. So if these two curves, they touch each other if c equals a plus b. Now here the question is, a curve is given by the equation x equals at square and y equals at cube. A variable pair of perpendicular lines through origin meets the curve at P and Q. Now suppose P is at1 square, at1 cube, and Q is at2 square, at2 cube. Show that locus of point of intersection of tangents at P and Q is 4y square equals 3ax minus a square. Now first, these two lines, they are perpendicular. What is slope of OQ? Slope of OQ is T2 and slope of OP is T1. And since they are perpendicular, we can write T1 into T2 is minus 1, and that's our first equation. Now we'll find dy by dx. Dx upon dt, it is 280, and dy upon dt is 3at square. So we can write dy by dx is 3t by 2. So we can write equation of tangent at any point, it is y minus at cube, and it is equal to 3t by 2 x minus at square. So we cross multiply, we can write 2y minus 2at cube will be equal to 3tx minus 3at cube. So we can write this equation as 3tx minus 2y, and it is equal to a t cube. Now at t, parameter is t1, so this equation will be 3t1x minus 2y equals at1 cube, and for q it will be 3t2x minus 2y and a t2 cube. Now we subtract second from first, we can write 3 t1 minus t2x, and it will be a t1 minus t2 t1 square plus t2 square plus t1 t2. Now t1 minus t2 will cancel. We can write x equals a by 3 t1 square plus t2 square, and then t1 t2 is minus 1, and this is the first equation. And if we put the value of x in this, we can write 3t1x will be a t1 cube plus a t1 t2 square minus a t1 minus 2y equals a t1 cube. Now a t1 cube, it will cancel. Now here t1 into t2 is minus 1, so we'll get 2y equals minus a, and here will be t1 plus t2. That's our second equation. Now we need to eliminate t1 and t2. So from this first we can write t1 square plus t2 square as 3x by a plus 1, and we square this one, we can write 4y square upon a square. It will be t1 square plus t2 square plus 2t1 t2, and which is minus 2. So we'll take this 2 here. So we equate them, we can write 3x by a plus 1 will be equal to 2 plus 4y square by a square. So it will be 3ax, and it will be equal to a square plus 4y square. So the required locus is 4y square equals 3ax minus a square. 4y square equals 3x minus a square, and which is what we need to prove. Now in question 3b it says the graph of 2x square plus xy plus 3y square minus 11x minus 20y plus 40 equals 0 is an ellipse in the first quadrant of the xy plane. Let a and b be the maximum and minimum value of y by x over all the points x comma y on this ellipse. We need to find the value of a plus b. Now we are given that this is some general ellipse which lies in the first quadrant. So this is some general ellipse. Now it says we need to find maximum and minimum value of y by x. Now for any point, if we join this point to origin, we'll get this line whose slope is y by x. So this slope, it will be maximum and minimum when this line will be tangent to this ellipse. Now say this value is m1 and this value is m2. Now suppose this line is y equals mx. Now this line y equals mx, it must be tangent to this given ellipse. So for condition of tangency, we'll use quadratic method. So what we'll do is we'll eliminate y. We'll write 2x square plus x into mx plus 3 m square x square minus 11x minus 20 mx plus 40 equals 0. Now we'll take x square common. We can write 2 plus m plus 3m square into x square minus 11 plus 20m into x plus 40 equals 0, which is a quadratic equation in x. Now since these two curves, they are tangent, that means this equation should have only one real root. So the condition will be, for this equation, discriminant must be equal to 0. Now if we put d equals 0, we'll get 11 plus 20m whole square minus 4 2 plus m plus 3m square into 40 will be equal to 0, which is 121 plus 400m square plus 440m minus 320 minus 160m minus 480 m square equals 0. Now we can write this equation as 80 m square minus 280 m and plus 199 equals 0. Now there are two such tangents possible. So that means this equation will have two roots, m1 and m2. Now it says the smallest value is a and the largest value is b. So this m1 is a and then m2 is b. So we just need to find the value of a plus b, which is nothing but sum of roots m1 plus m2. And for this equation, sum of roots is minus b upon a, which is 280 upon 80, and that is 7 by 2. So the value of a plus b will be 7 by 2. Now here the question is, prove that the segment of tangent to the curve y equals a by 2 log a plus under root of a square minus x square upon a minus under root of a square minus x square minus under root of a square minus x square contained between y-axis and point of tangency. So this distance, we have to prove that this distance is constant. Now again in this case, we'll change it in parametric coordinates. So what we'll do is, we'll say let x equals a sine theta. Now if we put x as a sine theta, we'll get y as a by 2 log, and this is a plus a cos theta upon a minus a cos theta and then minus a cos theta. So it'll be y equals a by 2 and this is log 1 plus cos theta is 2 cos square theta by 2 and 1 minus cos theta is 2 sin square theta by 2. So it'll be cot square theta by 2 minus a cos theta, or we can write this as a log cot theta by 2 minus a cos theta. So this is our point, say P, which is given by a sin theta, comma a log cot theta by 2 minus a cos theta. Now we need to find equation of this tangent. So first we'll find slope of the tangent. If we find dy by d theta will be a, and this is 1 by cot theta by 2 minus cosec square theta by 2 into 1 by 2 and plus a sin theta. Now this is 2 sin theta by 2 cos theta by 2. So we can write this as minus a upon sin theta plus a sin theta. So it will be minus a cos square theta upon sin theta, and if we find dx upon d theta will be a cos theta. Now dividing first with second, we can find slope of this line. We'll get dy by dx as a cos square theta upon sin theta upon a cos theta, which is nothing but minus cot theta. Now we have this point x comma y, say this is h and this is k, and we have slope of tangent. We can write this equation as y minus k equals minus cot theta x minus h. Now we need to find point of intersection with y-axis. Now for y-axis, we'll put x as 0, and if we put x as 0, we'll get y as k plus h cot theta. So point of intersection with y-axis is 0 comma k plus h cot theta, and this point of tangency is h comma k. We need to prove that this distance is independent of theta. Now we use distance formula. We can write this is under root of now h square plus, and this is h square cot square theta. So it will be h, and then under root of 1 plus cot square theta is cosec theta. So it will be a sin theta into cosec theta, and it will be simply a. So this distance from the point on y-axis to point of tangency will always be constant, and it is equal to a. And this is what we need to prove. Now question number 2 is, by definition, a region inside a parabola is a set of points a, b such that b is greater than or equal to a square. We are interested in those circles all of whose points are in the region. A bubble at a point on the graph of y equals x square is the largest such circle that contains p. Now you may assume the fact that there is a unique such circle at any given point on parabola. So we have this parabola y equals x square. And then at any point P, we have to draw the largest circle. Bubble is the largest such circle that contains P. So any largest circle which contains P, it must be tangent to this parabola. And it will also touch corresponding point on the left hand side also. So let this point P be h comma h square. Now this P dash will be minus h comma h square. Now this circle, it touches this parabola at this point P. Now since this circle, it touches this parabola, that means they should have a common normal, and any normal to circle, it passes through center of the circle. And from symmetry, we can say that center of this circle will lie on y-axis. So let the center be 0, k. Now we drop this perpendicular, then this length, this is h, and this point is 0, h square. So let the center be C, and let this point be Q. Now the first part is, if the radius is 1, find the center of this bubble. First what we'll do is, we'll find relationship between h and k. We'll find slope of normal to this parabola. So if we'll differentiate, we'll get dy by dx, and it'll be simply 2x. Then slope of normal at point P, it will be minus 1 upon 2h, and slope of normal, it must be equal to slope of this line, which is h square minus k upon h. Now we'll cancel this h with h. We'll get k equals h square plus 1 by 2. Now it is given that radius of this circle is 1. If the radius is 1, and if we use Pythagoras theorem, then we can write this length, which is k minus h square whole square plus h square, and this is equal to 1. Now what is k minus h square? K minus h square is 1 by 2. So it will be 1 by 4 plus h square is equal to 1. So value of h is plus or minus root 3 by 2. Now if the value of h is 3 by 2, then we can find k. So value of k will be 3 by 4 plus 1 by 2, and there will be simply 5 by 4. So center of this circle will be at 0, 5 by 4. And that's your first part. Now what about its second part? Find the radius of the smallest possible bubble at some point on the parabola. Now from this normal condition, we have already worked out k minus h square is 1 by 2. So this distance between C and Q, this is fixed, and this value is 1 by 2. So we can write r square as 1 by 4 plus h square. So that means this r square is always greater than or equal to 1 by 4. So the minimum value of r will be 1 by 2. And we'll get this value minimum when the value of h is 0. So smallest bubble, it will be at origin, and its radius will be 1 by 2 units. We generally study questions on number of common tangents between two curves. Now here the question is, we have to find maximum number of common normals that can be drawn to these two parabolas. Y square equals 4ax and x square equals 4by. So what I'll do is, I'll start with this first equation. For the parabola of the first form, equation of normal is y equals mx minus am cube minus twice am. Now I'll consider the second equation, which is x square equals 4by. Now the relation between first and third form is, if I interchange x and y, I'll get third form, x square equals 4ay, or in this case, which is x square equals 4by. So for this equation, I can write equation of normal as x equals m dash y minus b m dash cube minus 2b m dash. So again, what I'll do is I'll write it as m dash y equals x plus b m dash cube plus twice b m dash. I'll divide by m dash. I'll write y equals 1 upon m dash x plus b m dash square plus 2b. So that is the equation of normal for this second form, x square equals 4by, and for the first form, equation of normal is y equals mx minus am cube minus twice am. Now we are looking for common normal. So we are looking for equation of a line which is normal to both the curves. So that means both the equations should represent same line. So if both the equations represent same line, in that case, if I'll compare coefficient of x, I'll get m equals 1 upon m dash, and also I'll get am cube minus twice am, and this is b m dash square plus 2b. So from here I'll write m dash as 1 upon m. So I'll write am cube minus twice am b upon m square plus 2b. So if I'll multiply, I'll get minus am to the power 5 minus twice am cube plus b plus 2bm square. So I can write this equation as am to the power 5 plus twice am cube plus 2bm square plus b equals to 0, which is an equation of degree 5. So any fifth degree equation can have at most 5 real roots. So this equation will have at most 5 real roots. Now most of the books and almost all YouTube videos and study material, they give the maximum number of common normals between the two given parabolas, pi square equals to 4ax and x square equals 4by as 5. Now this fifth degree equation, it may not have 5 real roots. So what we'll do is, we'll look at this equation a bit. I'll divide this equation with a. So I'll write m to the power 5 plus 2m cube plus 2 b upon am square plus b upon a equals to 0. Now I'll take this b upon a as some other constant, which is lambda. So I'll write this equation as m to the power 5 plus 2m cube plus 2 lambda m square and then plus lambda equals to 0. So I can write this equation as m to the power 5 plus 2m cube, and then I'll take everything on the right hand side. I'll write minus lambda, and this is 2m square plus 1. So we can rewrite this equation as m to the power 5 plus 2m cube upon 2m square plus 1, and this is equals to minus lambda. Now if we'll consider a function fx, which is x to the power 5 plus 2x cube upon 2x square plus 1. So domain of this function is x belongs to R. Now if we'll differentiate this function, if we'll find f dash x, then derivative of this function will be 6x to the power 6 plus 9x to the power 4 plus 6x square upon 2x square plus 1 whole square. Now since all the powers of x, they are even powers, so that means this expression is always greater than or equal to 0. So that means this function, it is an increasing function and x belongs to R. So we'll draw the graph of this function. This function will be an increasing function. Now we'll need to find number of solutions of this equation, which is x to the power 5 plus 2x cube upon 2x square plus 1 equals minus lambda. So one of the function is x to the power 5 plus 2x cube upon 2x square plus 1, and the other function is y equals minus lambda, which is a straight line which is parallel to x-axis. So if I draw this straight line, so this straight line, it will intersect the graph at only one point. So there'll be no other point of intersection. So even when this equation of degree 5, it cannot have 5 real roots. So the only possibility in this case is it will always have exactly one real root for all values of a and b when a and b they are unequal to 0. So maximum number of common normals between these two given parabolas will always be 1 and not 5.